Okay, here we are with Chapter 6, Test Review Part 1. We're going to be working with numbers 5 through 7 in this little video, so let's get ourselves settled on problem number 5 here. Okay, so now in this particular problem, they're asking me which of the following ordered pairs is a solution to the system of equations. You have some options, of course. You could go through and actually solve this system running substitution, or you could use elimination and start to solve that way. You are also welcome to take these answers and start plugging them in. Of course, the first number is the x value, and so you would plug it in for x here. Then you would plug in the second value for y and find out if this winds up being true. So you're going to check the veracity. But the problem with this is that you have to plug it into both equations, and both of them have to be true. And then you have, of course, 4 different options to choose from, so that one could take some time. But you are welcome to run it that way. You could, of course, also graph these and find the solution that way. I am going to go ahead and run elimination. I'm going to eliminate my x's and solve for y. I have a pretty good idea of what the answer will be, but once I have that answer, and I'm sure, then I can quickly find the rest of it. So, to eliminate the x's in this problem, I'm going to take the bottom equation and multiply it by -1. Since the x's both have a coefficient of 1, I have the coefficients I need. What I need are opposite signs. So the top one remains the same, and so I have x plus 7y equal to 12. And then we have multiplying through by a -1, I wind up with -x minus 4y equal to -3. The x's now cancel each other out. 7y minus 4y is 3y, and 12 minus 3 is 9. Dividing both sides by 3 will get me the answer I kind of thought it was. Y is equal to 3. Now, unfortunately, you can see that 1, 2, 3 of my answers have the same y value, so I can't get rid of any of these, but I can get rid of a. That has a y value of -9. So what I would do now is to take this 3, and I'm going to choose one of my 2 equations. I can choose the top equation or the bottom equation, it does not matter. You can even come over here and choose the altered equation, but I tend not to use this. I like to go back to the original. So I'm going to take this y equals 3, and I'm going to plug it in down here. These numbers are a little bit smaller, I kind of like that. And so I'm going to replace the y with this 3 and then solve for x. I'm going to make a little bit of space here and get rid of these marks so that I've got some room to work. Okay, so I'm going to have x plus 4 times 3 equals 3. Well, 4 times 3, of course, is 12, so x plus 12 is equal to 3. Subtracting 12 on both sides will get me an x value of -9. And so that sends me to my answer of B. All right. Heading over now to problem number 6. This is a graphing problem. Remember that whenever we graph, we are looking to use the slope-intercept form, so I am looking to make sure that I have the y equals mx plus b form, and then we use the acronym BAM to graph. We begin with b, this is the same b that sits back here, that is the y-intercept, and move with m, and that's the same m that sits here that represents the slope. Now, it turns out that this first equation is ready to go, and so I'm going to use some color here when I do this one. I'm going to use red for this top equation. And so I begin by starting at -2. So we come down here to -2 and put a dot. And then I'm going to use my slope, which is -4/3. Remember that a negative can either go to the top or to the bottom, but it cannot go on both. If I put that negative on both the 4 and the 3, we get a positive. So one direction is negative and only one direction. So I'm going to start by going down 1, 2, 3, 4, and then over 1, 2, 3, and put a dot right there. I am graphing a system of equations. I am going to wind up putting dots until I reach the edges of my graph. So I'm going to go down again 1, 2, 3, 4, and over 1, 2, 3 to sit right there. I will also go up, choosing the number 4 to be positive and the 3 to be negative this time. I'll go up 1, 2, 3, 4, and to the left 1, 2, 3, and that puts me there. Then repeating that process, up 1, 2, 3, 4, and over 1, 2, 3. It looks like we can get in one more time, up 1, 2, 3, 4, and then over 1, 2, 3. Now, at this point, we have enough to be able to draw my line, and so I will sketch my graph. I apologize for the shakiness of my line. I've gotten kind of used to my other note-taking software where when I hold the pen down it just makes my line nice and straight, so I apologize for that. But the points are what are important. Now, as it comes to the next line, this one is not ready to graph, and so we're going to spend a minute solving this one for y so that it's in that y equals mx plus b form. First thing to do is add 2x to both sides, and that leaves me with 3y equal to 2x plus 12, dividing by 3, dividing by 3, dividing by 3 will leave me with y equals 2/3 x, and then plus 4. It's important to remember to divide everything on both sides, and that when you get division that doesn't turn out to be nice and pretty, we leave it in its fraction form. So I begin with b, which in this case is 4, so we go up to 4 on the y-axis. So up 1, 2, 3, 4, and we start right there. Now this time my slope is 2/3, both positive, so I can go up 1, 2, and then over 1, 2, 3, up 1, 2, over 1, 2, 3, one more time, up 1, 2, over 1, 2, 3. I can also go down, making both of them negative, which, remember, 2 negatives make a positive, so going down 1, 2, and then over 1, 2, 3. It looks like we have our intersection, which is what we want. And then down 1, 2, over 1, 2, 3. Down again, 1, 2, over 1, 2, 3, and that's about as far as I'll get on this one. Oh, sorry, I apologize. It looks like I may have messed up that second one. So I need to kind of fix this one, which of course is going to change this one. Not going to change my answer, but I do want my graph to be correct. So I'm going to come in here and erase that and try that one more time. We'll go down 1, 2, and this time over 1, 2, 3 to sit there. Down again 1, 2, and then over 1, 2, 3. And then when we sketch this line, we get this. Now what I am after, of course, is this intersection right there. Looking for me to name the solution. Whenever we name a solution, we do so with the ordered pair. And so this sits at, if we count it over, we sit at, let's see, here's 1, 2, 3, negative 3, and then up 1, 2. This sits at negative 3 and positive 2, negative 3, positive 2. That's my x value, my y value, and the ordered pair that they create. If you don't make this as an ordered pair, putting it in parentheses, then of course, unfortunately, you have not followed directions and we have to count it wrong. All right. Now number 7 is the same kind of problem. Looks like we'll be doing a little bit of work for both of these, however. I am going to go ahead and start with the bottom one this time. I'm still going to use blue on that one, and so we'll graph this one first. I'm going to divide everything by 4 this time. The y is mostly by itself, so we wind up with y equals, now 10 over 4 will reduce. They're both divisible by 2, and when I divide 10 by 2 I get 5. When I divide 4 by 2 I get 2. So 5 halves x, and then negative 3. So starting my graph at negative 3, and then using my slope of 5 halves to go up 1, 2, 3, over 1, 2, or sorry, I apologize, up 5 and over 2. Let's try that again. Up 1, 2, 3, 4, 5, and then over 1, 2. Again, up 1, 2, 3, 4, 5, and over 1, 2. Looks like the next one would take me off of my graph. So now we'll head down 1, 2, 3, 4, 5, and then over 1, 2. And so we get this lovely graph that looks like this. The next step then would be to take that equation on top, and we are going to need to do a little bit of work to get that one ready. Start by copying that down and starting to solve for y. Subtracting 5x from both sides will get me a negative 2y equal, I like to put my x values first, so negative 5x, and then the 6 is positive, so it becomes plus 6. Then dividing everything by negative 2 will get me y equals, now here we can see that we have a negative here and a negative here, so two negatives become a positive, and so this turns out to be just positive 5 over 2x, and then of course we have the 6 divided by negative 2, which is a negative 3. Now it turns out, of course, that if you look at your equations, you can tell here that this, oops, I don't want a pen, I want a highlighter. Let's grab that highlighter instead. As you can see, this equation is exactly the same as this equation. When I go to graph then that second line, it turns out that I graph the exact same line, and so they intersect everywhere, which means, of course, that my solution, my answer is infinitely many solutions. And what a lot of people, sorry, let's try to spell solutions correctly here, solutions. What a lot of people will write instead is just IMS, infinitely many solutions, right? All right. So that takes care of the front page, and so my next step, of course, will be to take a look at the next page. We'll probably try to work that one just a little bit quicker. The explanations are here. I think on the second page we'll just kind of work them out, and you'll be able to see how this works. It probably won't be much commentary on this one. So up next, Chapter 6, test review part 1, and then we'll do the I do, and we'll do the whole page in one fell swoop. All right, thanks, and keep watching.